Hello and welcome to a new tutorial in your YouTube channel Science and Engineering, and today would like to talk a little bit about active and passive components in electric circuits. So many of us have seen different components in an electric circuit, starting from resistors, inductors, diodes, capacitors, transistors, different types of transistors, voltage and current sources, transformers, and relays. And there are different ways actually to look at these components. So some of these components, like for example resistors, inductors, and capacitors, are seen as linear components. And by linear components we mean that the components that have like a linear behavior, so they would follow Ohm's law. So any linear change in the voltage will cause a linear change in the current, and vice versa. Some other components like diodes and transistors, and maybe these also relays, they have a non-linear behavior, so they don't follow Ohm's law. But still also we have some resistors here that do not follow Ohm's law, like thermal resistors that are used in the PT sensors to sense the temperature. So they would be linear in some part of the operation, and in another part they are non-linear. So some variable resistors also are considered to be non-linear resistors. Some components are also seen as being active components, and some components are being seen as passive components, which is the topic of our tutorial today. And some components also are seen as pure electric components, like most of these components. Some others are seen as a mix of electromechanical components where there is electromechanical effect. So for today we will just focus on the active and passive components, and we will not talk about the electromechanical components, since this is a different category in the components in our circuits. So let's start by looking at active components versus the passive components. And if we look at this circuit, it looks pretty complex here, but it has many components: transistors, capacitors, variable resistors, constant resistors, transformers, which is like two coils, two inductors with a different turns or same turns. And if we want to think about what could be here an active component and what could be a passive component, so intuitively, active means something active, something that has to do something. So, and passive is something that is, its behavior is kind of passive. It's not, it is receiving. It is not a donor or something like that. So, one rule here of the thumb that we have to always mention, that for any electric circuit, in order to be live circuit, there must be at least one active component. So we need at least one active component for a circuit to be live. Otherwise, if all the components in a circuit are passive, then the circuit will not operate. So this is one rule. And if we, according to also Newton's third law, that for every action there is a reaction equal in magnitude and opposite in direction, then for this active component there must be also at least one passive component to consume the energy or the power generated by the active component in a circuit. So this is the basic rule in any electric circuit, that at least one active component and at least one passive component. So if we start looking at passive components, and if we look at this RLC circuit, a famous circuit in electrical engineering, and here we have a AC voltage source. So if we start looking at which element in this circuit could be active and which can be passive, well, a resistor, the current will pass through this resistor, so there will be a power consumption here. Similarly, the current will pass in this coil or in this inductor. And if this conductor is an ideal conductor, it will be stored in the form of a magnetic field. And again, the current will go through this capacitor. And again, if this capacitor is an ideal capacitor, then it will be stored in a form of electric field. So these components actually are seen as passive because they are not generating any energy in the circuit. And without the voltage source, nothing will happen here, nothing will operate. So this gives us the first definition of what is active and what is passive. So this voltage source will generate power to this circuit. It can be an AC voltage source, DC voltage source, or a DC current source. So a passive component will only receive the energy. These three components, the R, L, C, will only receive the energy. And then the behavior will be different. It can either dissipate the energy in case of resistor, or absorb the energy in case of inductor and capacitor, if they are ideal and there is no parasitic resistance inside it, which is something ideal that we don't have. Bearing this definition into mind, then we will start to look at some other components and tell if they are also active or passive. So if you look at this circuit, there's a voltage source here, and there is a transistor here and two diodes here. Well, the diodes are seen as elements in the electric circuits that control the direction of the flow of the current. So they can either allow the current to pass in this direction, and they don't allow the current to pass in this direction. Do they add any energy to the circuit? No, they consume power and energy from the circuit. So you need some voltage here to operate this diode. So we can consider the diodes as passive components, again, similar to the resistors, inductors, and capacitors. What about the transistor? Well, one of the main functions actually of the transistor is to amplify a signal. So if there is a voltage here at the base of this, there's a base and there is a collector and this is the emitter. We will discuss this later in the tutorials for transistors. But for the time being here, if a signal is fed to this transistor, and here is the input and there is the output, then this signal will be amplified here at the output. And because of this behavior, this amplification, we will say that this transistor is an active component. So this makes a transistor and also operational amplifiers and different types of transistors and active components. So again comes the question that we said that the active components are those which are supplying energy to the circuit. But if we look at this transistor, actually it needs a power to operate this transistor. Yes, it has amplified the signal, but is it a pure source of energy in this circuit? We can see that it has done something, which is it has controlled the charge flow. The charge flow in any circuit is actually the current flow. And we have seen that the current entering to this transistor has been amplified here. Similarly, the voltage here has been amplified. So what could this mean? If we look again, if you want to redefine the definition again of passive and active components, and if we look at this passive components here in this circuit, we can see that, and compare it to the active components here in this circuit, we have seen that the signal here entering to this transistor has been amplified. So the voltage has been amplified, the current has been amplified. Whereas in this passive circuit here, nothing has been amplified. In fact, the current passing through this resistor has caused a voltage drop across this resistor. So if this is a 10 voltage, if this is a 10 voltage power supply here, So after this resistor, it might be 8 volts only. And maybe after this inductor, there is some also voltage drop here across this inductor. Then it becomes maybe 5. And again, similarly, after this capacitor, from 5 to the ground again. So this cannot amplify a signal power. So this gives us actually a better definition of what could be an active component and a passive component. A passive component cannot amplify a signal power, whereas an active component can amplify a signal power. Because in the end, if we look at the transistor, it is really not supplying energy to the circuit. In fact, it is operated by this voltage. It needs a power, it needs energy to operate. And the amplification that happened here from this point, the input point here to the output point here, was done by the energy supplied through this voltage source. So it has used the energy from a real active source here to amplify a signal. So one last thing is about the transformer, and we know that a transformer is, simply speaking, is just 2 coils. The first coil here is the primary coil, and the second coil here is the secondary coil, and they have different turns ratio. And here is the primary supply, and here is the secondary output from our transformer. And the purpose actually is either to increase this voltage here, VP here, at the supply. We get a higher voltage. In this case, it's called a step-up transformer, or to decrease this VP, to decrease the supply, the input voltage here, to get the less voltage here. In this case, it's called a step-down transformer. And for an ideal transformer here, we have these equations here that the ratio between the primary side voltage and the secondary side voltage, the ratio between this input and that output, is given by this relation. It is a ratio between the currents here in the primary circuit and the secondary circuit, or it's a ratio between the number of turns in the primary side and the number of turns in the secondary side. And this applies for an ideal transformer. Now the question comes, is a transformer an active or a passive component? Well, if we consider what happened in the case of the transistor, we have seen that the transistor has amplified the signal. So one can argue also and say that, okay, if we give it here for this, if we give this transformer 100 volts here at this side, and it is a step-up transformer, and we get here 300 volts, for example, that we can consider this transformer as an active component in our circuit. Well, this might be a bit confusing, because if we look at these equations here, this part of the equation, we see that the ratio Vp over Vs is equal to Is over Ip. So if we do a cross multiplication here, it means that Vp multiplied by Ip is equal to Vs multiplied by Is. This means that the power, because the power is the multiplication of voltage and current, the power at the primary side is exactly equal to the power at the secondary or the supply side. So there is no amplification of power. And since there is no amplification of power, then a transformer cannot be seen as an active component. What happens in the case of the transistor, if you go a little bit step backwards here, we see that the signal, the current here, has been amplified, and also the voltage has been here also amplified. Two of them has been amplified. This means that the power has been amplified. That's why we call a transistor an active component, while a transformer is a passive component, since the power is reserved and not increased. So I hope this give us a little bit information about active and passive components. I hope you enjoyed the tutorial. If you have any comments or questions, you can put it down in the comments below. Thank you, and until then.